Welcome to Control4 Driver Development Essentials. My name is Peter Casenza. In this video, we'll take a close look at control methods. When we refer to control methods, we're talking about the manner in which data is delivered throughout the device driver architecture through a defined means of commands and functions. These commands and functions are delivered as part of the DriverWorks SDK, and they are specifically designed for each of our supported control types: serial, TCP/IP, and IR. Throughout the course of this video, we will review these functions and look at some code examples of them in use. We previously addressed each of the control methods in a 301 level video. Module 3, Device Communication Across the Control4 System, offers an overview into each of these control types. If you haven't had a chance to view that material, we recommend that you do so prior to proceeding with this video. Let's start with some overview information that is applicable to all of the control methods that we'll review. First, you will need to declare the type of control method you plan on using. This declaration is made in the XML part of your driver, and it's one of the settings configured on the main tab of Driver Editor. If we open up a driver in the Driver Editor environment, we can see the control method drop-down list on the left-hand side of the page. Setting your control method here is as easy as clicking on the appropriate method from the list. As you write drivers, you'll find that the APIs for moving data between proxies, protocols, and devices are defined using a send and receive convention. For example, let's look in the DriverWorks API reference guide for some of the commands that we'll discuss in this video. If we open the Serial Network Device Interface section, we find several APIs relevant to this training. Here is the Send to Serial function. It is used to send data from the protocol driver to the device. Obviously, this function is used for a device controlled via serial communication, like RS-232. Similarly, we can also see that there's an API called Received from Serial. This API handles data coming from the serially controlled device to the protocol driver. Keeping in mind this send-receive convention will be helpful as we review the various control methods. Since we're discussing serial API commands, let's stay with serial-controlled devices for now and look at some examples of the send to serial and receive from serial APIs. We'll use the driver editor environment to open up a serial-controlled power management device. If we look at the script tab under the codes commands area, we can easily find where send to serial is defined in the driver. Simply click on the Functions tab on the right-hand side of the screen, locate Send to Serial, and double-click on it. Here we can see that the Send to Serial requires the binding ID of the serial interface that was modeled in this driver for data communication. The ID value is defined under the Connections tab. If we open that up and click on the serial connection, we can see that our binding ID for this driver is 1. If we go back to our code, we can also see that the send to serial's other parameter is the actual command in string format. At this point, we've looked at how to send commands to a serially controlled device from our protocol layer. A significant benefit to writing a serial driver is that many serially controlled devices can also provide feedback to the Control4 system. That's where the Receive from Serial API comes into play. Received from Serial handles data that comes from the device to the protocol driver. Here is where we've defined Receive from Serial in our driver. Just like Send to Serial, it requires the binding ID and the data being received in a string format. At this point, we should note that data structures will need to be parsed and formatted properly. This is applicable when data is sent from the protocol to the device and vice versa. Parsing and structuring data is a significant part in driver development. However, due to its complexity, this topic falls outside the scope of this video. However, in the next training module, we'll look at data structure and how data can be parsed. Next, let's take a look at a network driver that uses the TCP/IP control method. This is a DVD player driver, and based on the control method defined on the main screen of Driver Editor, I can tell that it's a network driver. If we look under the Codes Command Script tab, we can find where the Send to Network API is defined. Send to Network functions very similarly to Send to Serial. It handles data coming from the protocol to the device. We can also see that it requires 3 parameters. The first 2 are the network binding ID and the network port that receives the data. These are both configured under the Connections tab in Driver Editor. The third parameter is the data itself in a string format. The other half of our communication architecture can be seen in the Received from Network function. Just like the Send to Network, it requires the binding ID, the data port, and the data being received in a string format. The last control method we'll review in this video is IR. IR is somewhat different than the serial or network control methods in that its communication path is only one way. A driver can send an IR code to a device using the Send IR API. However, the device cannot send IR feedback to the protocol. So, a function such as Received from IR doesn't exist. Another aspect that makes IR unique is how IR codes are handled in a driver. The physical IR code resides in the XML part of the driver. If we open up the IR Codes tab in Driver Editor, we can see all of the commands that have IR codes. If I hover over a code, such as Power On, I can see the actual code. Again, these codes reside in the XML part of the driver. When we add a code to our driver, it's assigned an ID. This ID represents this IR code, and it is needed by the Send IR API. Here is where we've defined Send IR in our driver. It requires the IR binding ID as its first parameter. The second parameter is the ID code value for the IR code. Unlike the other control method APIs, it supports an optional parameter, which is the proxy binding ID. When fired, Send IR will reference the ID code passed in the API and send the IR code to the device. As we mentioned earlier, IR drivers provide no feedback, so Send IR represents the only API needed for the IR control method. Hopefully this video provides you with a better understanding of the functions and APIs needed to send data from the protocol to the device and receive data from the device to the protocol. It represents a critical component of a driver, and learning to use the provided SDK elements correctly will make your driver development efforts easier. Now that you have an understanding of how data is sent and received, our next video will look at how the data needs to be handled and parsed so that communication between devices and the Control4 protocol and proxy layers is successful.